Hello, everyone, and welcome back to our exciting new learning series. Today, we are diving into another fascinating topic generative AI. With AI becoming increasingly popular, you've likely heard the term before. But what does it really mean? To explore this in more detail, I'll hand it over to my colleague, Dharmesh, who will guide you through the key concepts and applications. Over to you, Dharmesh.
Yeah. Uh, Thanks, Arya, for the introduction. So, before we move to understand what is generative AI, let's discuss some of the key terminology which is popular in AI world. I'm sure you might have heard this somewhere around you. Just a short disclaimer before we start discussing is that intention behind this series is not to explain it very deep level and mathematical terms, uh, but we will try to give you the overview and basic understanding so that based on your use cases or your interest, you can further explore it more. So those who already are working on this domain and really expert in this field, then apologies in advance. Additionally, we are from the automotive background. So with our experience, we will discuss about the use cases and where currently we are seeing the AI being used in automotive domain. So yeah, with this disclaimer, then you can see on my screen some of the key terminologies. So first term is the AI, artificial intelligence. So in simple terms, AI refers to machine or software that can perform tasks that typically require human intelligence. Now, what is intelligence? So, well, it could be a lot of different things, but generally, we tend to think that uh, of it is as ability to learn, to infer, and reason things like that. So, if we look at the timeline on the right side, you can see it here. Uh, so, around 1950s time frame, it's already AI was started, and on those days it was very premature, so most of had not even heard about it. It's basically was a research project, and those days people used the programming language like Lisp and Prolog, etc. So this kind of things later become known as the expert systems. Now this system used to perform certain tasks, and in 1980s, maybe in early 19 also, the next term become popular and interesting is the machine learning. So the machine learning, you can see it here, the definition. So ML is subset of the AI where machine learns from the data without being explicitly programmed. So instead of following the fixed rules, uh, by finding the patterns. So for example, if we I can give an example. You have a pattern. First, let's consider the shapes. So rectangle, square, triangle, again rectangle, square, triangle. If I keep on giving this and ask you to predict what's the next, then by this pattern, you will come to know, okay, next after square, you will come to the circle. So similarly, these patterns machine can also observe, and that's where this machine learning is important. So machine learning, what it does is, or what it is very good at it, is finding the patterns. And I don't have to program it. I give a lots of information, and it observes the things. And if we provide these informations, shapes, then automatically it will try to learn. So if I take an example where it is used in automotive, so automotive we previously discussed in one of our video where we're discussing IDS. That's where the anomaly detection. So we were detecting is there malicious package in the network. So if machine learning is placed, and then it will try to analyze and identify if anything is out of the pattern. So that's where we use the machine learning in automotive, especially in the IDS system. So yeah, as I mentioned, machine learning algorithm is really good at looking at the pattern, discovering the pattern within the data. Uh, so next thing in this diagram also you can see is the deep learning. Uh, mm, so deep learning is again subset of the machine learning. So for the deep learning, uh, what is core behind the deep learning is the neural networks. So it is inspired by the human brain to process the complex data like images, speech, or text. So we will discuss more on the details on the neural networks in the coming slides. So this also reaches some popularities during the 2010s and afterwards, and as something that is we use till today as the basis for all our next AI innovation. So the most recent advancement in the field of artificial intelligence uh, are called generative AI. So it's again a subset of the deep learning, where generative AI also leverages the large language model, and these models are basically internally uses the neural networks. So which is where we take languages and model it and make prediction in this technology, where if the word will be given, then what would be the next word or next sentence or next paragraph, etc. is happening. So these are some of the definitions and key terminologies which you might be aware when we discuss about the generative AI. Then going on to the next slide. So here we have how does this generative AI works. So there are basically three core technologies involves to generate the new content. The first one is the neural network itself, then the transformers, and the third one is the diffusion models. So we will be discussing each of these terms in coming slide. A very important prerequisite to work with these technologies is to training process. So it would require a huge amount of data to train such technology, and that's where it is very important that you should have a proper and large amount of data set in order to behave or work this technology properly. uh, so I means generative AI, some people also refer that it is not really generating new content, but it is utilizing the existing content. Then how does it call the generative AI? But if we give an analogy, for example, the music, then music, we all know, will have seven core notes, and by shuffling these notes and again rearranging it, you are generating the new music. So that is how still the people are producing or composing new songs, and that we are not calling like something which is already existed. We say that it's generated newly. So similarly, this generative AI also works. So you have huge amount of data sets or knowledge, and then you are just generating based on the use cases, new things. And at the end, it's just the NLP, natural language processing. So it is very important that the training data, whatever you have, that should be proper and sufficient amount to perform or work this technology better. So now let's discuss each of these in little more detail. So first one is neural networks. So what is it? So a definition is a computational model inspired by the human brains, consisting of interconnected layers of nodes, which is called neurons. So in this first image, you see it's basically consists the three layers. One is the input layers, then you have hidden layer where you have different nodes or called neurons, and then you have output layers. So with analogy, if we want to understand, then on your screen below you see the image of animals. Let's take an example that this image is given to the group of students, and those students never have seen this animal before, and you ask them to answer or just tell whether this image is from koala or not. So this koala is the animal from Australia, uh, and most of the students doesn't know what it is. So our task is to train them. Now on the right side of the figure you can see that we divide this task into smaller works, and for example here student blue will be associated only to recognize the eyes and then tell whether it is cola size or not. Similarly, white will be assigned to nose, and brown will be assigned to detect the ears. So once they have this task, uh, then they will get the output. So they should score between 0 to 1. So 0 means it is definitely not the cola size. Uh, zero point 0.5 means, yeah, it might be or it might not be 50-50, whether it is the correct size. And the 1 means definitely it's a cola size. Now this result they will pass to the next layer. In this case, let's say who is supervising them. So next person or next student read. So he will collect all this information and he will multiply it with some weight. For example, the nose of koala is very unique, so it is different from other animals. So he will have higher weights. So he will consider again divide these weights into 0 to 1. For example, nose he have given 0.5, and from person white or student white he got 0.2, then he will multiply it with 0.5. Similarly, from person blue he will multiply it with 0.2 and brown 0.3. That's how he calculate the score and then passes this information to the next person, next supervisor, and then he will again check whether he got the perfect score or not, and based on that he will decide, okay, this is the cola or not. Now this process repetitive. So for example, once you get the final image, then the supervisor outside of the classroom knows exact what is cola and not, and then he will passes this information if suppose this is wrong. Then again this will go backwards. He will inform to person red and pink that this is wrong. Then they will inform to the previous students, and then they will mark this, okay, previously whatever I detected is false. And this is keep on with providing multiple images and many animals. This will keep on repeating, and at one point they will be mature enough or understand that okay, this image is from koala or not. So this is how the neural network works in just the analogy way. Of course, the mathematics behind is complex, and the yeah, purpose is not to explain that in detail, but yeah, just to give a overview. This is how the neurals are communicating or how it is learning. So yeah, as we discussed earlier, it is very important that you provide the enough information or data, and you train them so that it will give you the correct output. And next we discussed is the technology is the transformer. So this transformer is a type of neural network architecture itself, and this is introduced in 1970s. So there are different types of neural networks optimized for different types of data. Like if you are analyze the image, you would typically uses the conventional neural networks CNN, and since around 2012, the neural networks have been really good of solving those vision tasks like identifying the object or photos. But for a long time, we did not have anything comparably good analyzing to the language. So of course, vision we have the photograph detection, but for languages, we do not have that comparable model or neural networks where the translation or the text summarization or text generation is possible. And this problem is because the language is the preliminary way how the human communicates. So that's where it is important that something comes up. And you see until this transformers comes around, way how the deep learning is used to understand this. Let's take an example. We are converting the language, then translating one language into another. How it was happen? So it was happening via the RNN, which called the recurrent neural network. So this networks it will process sequentially word by word, and it will try to map and translate the thing. But this was not the efficient way of doing. And if we want to do like this, then you would have to provide so much GPUs to the RNN to actually train and learn the things. So that's where the next advancement or the things came in the research is the transformer. So transformer will mitigate those problems. One is it will process the parallel, so it will speed up the things, and also how this translation work is little different. So transformer, if we understand the in right side the image, you can see the complete workflow, how the transformer is designed and how it works, and also it involves the mathematical things, but we will not go in deep. But if we want to understand, then basically it's actually involve the three things. So the first one is the position encoding. Uh, so that is the first. Second is the attention, and the third one is the innovation is the self attention. So these three are the common things. So position encoding, let's start with that. So let's say we were trying to translate text from English to Hindi, and you take each word of your sentence before you feed it to the neural network. Then you also feed that with the numbers starting from 1 to 3, depending on at which place your word is in the sentence along with the word. And by doing that with a lot of words and information, it will try to then detect or rather try to understand how this language is being communicated. So neural network structure it will try to prepare by this, and this is process itself is called position embedding. So this will help in the transformer to actually translate from one language to another language. The next part in this is the attention. So attention mechanism is a neural network structure that allows the text model to look at the every single word in the organized the sentence when making decision how it needs to be translated. So while giving attention to one particular word, it will also take whole sentence and try to see uh, how it needs to be translated. But this is very old technique, or let's say attention is there. What new in this transformer is the self attention. So that's where it will try to also check the meaning or semantic thing and try to see whether it makes meaning or not. For example, if we have taken two sentences, for example, server, can I have a check? That is first sentence versus looks like I just crashed the server. So in these two sentences, the word server has the different meaning. And by just looking or pay attention to only one word, server will not give you full picture or the meaning. But with along with this, you have attention to one more word. For example, first sentence with server check, then you might know that okay, I'm talking about the human servant and not the one which is for the email, or in this case IT. So this is how this attention self attention mechanism works. So this also will be provided with the lots of data and lots of information. Then these neural networks would be easily learning about how the grammatically the language is built and what's the semantic meaning behind the language which is communicated. So that's where this transformer once uh, it came, then it is used in the many of the advanced natural language processing models we are seeing in the current days. So base for them is this transformers. And now next is the core technology. What we seen is the diffusion models. So again, this diffusion models is part of the basic neural network itself. But how does this work and what is specific about it? So if we go by the definition, so a generative model that gradually refine random noises into the structural image. So how does this works is basically you can see it on your the screen, that the image of dog. So this is completely new, and it doesn't mean that it doesn't existed or dog doesn't exist. So it is exist, and but the thing is when it is generated uh, by the model, this is completely new. So the same pixel you cannot find out in the internet or the actual image. And how this is generated is starting with the real data sample itself. So you have one image, then this image will be given to the model, then this erase image corruption will happen. So corrupting this data by gradually adding there is noise called specific Gaussian noise, and this will be destroying image until the data is purely noised. So then you cannot even detect okay what is underlying this image. And this process happens also the reverse way. So neural networks learns how to destroy the image, and from this destroy image then to come back to the original image. So not exactly original, but there will be a slight changes in the pixel, and that's how this new image will be generated. So this coherent until it become a coherent or very similar, till that point it will try to generate, and this is a reverse or denoising process. So that's how this is used, or uh, this diffusion model works. One of the example we'll see in the our applications also later, that this is GPT use this Sora SORA, where they are generating the images based on your provided text. So this behind this approach, the basic thing works is the diffusion models. So this is basically purely for the image generation. Okay, so now we'll talk about the architectures. So architectures is basically fundamentally you have some structure, and if you trained with this structured with the huge number of data sets and particular task, then it will become the models. So one of the architecture we have is the GPT, so generative pre-trained transformer. So this again used in the backend, whatever previously we discussed, neural networks and also the transformers and those things to develop this architecture. And this is also we will see in the some of the application or where it featured. Then the second one is the VAE. So it's a variational and auto encoder. So again, this is the another architecture type. And so the third one is the GN, Generative Adversarial Network. So what is it and how features, what are the feature it contains? Let's check one by one. So first one here is the uh, GPT, Generative Pre-trained Transformer. So what is it? So it's a family of large language model developed by the OpenAI. For example, you see GPT-3, GPT-4, and how does this work is this is using the transformer architecture, which is the we talked about how transformer works. So it's a self attention mechanism, and what are the data sets it's used to train, for example, books or article, or what are the things it can produce is you can generate the uh, paragraph or whole sentence or your document or even code. So that is one of the thing. And the third one is the predicts the next word within the sequence. So this called the autoaggressive generation. This also basic concepts like how the transformer works. So basically initially we send the RN and will generate the translate word by word, and then gradually we also seen once the transformer is developed, consider this is as auto filling. So when you type something, then it will predict like what is the next sentence or something. So that is also one thing is initially worked on is this generative AI. And key features for these models, or we can say the architectures. So this can generate the human like text, uh, then the translate languages, write a code, or answer a questions. We by now already we are using the chat GPT, Gemini, or some other models for doing all this activity, and we already know how efficient they are or how good they are with these tasks. So one of the key feature is fine-tuned for the chatbots. So chatbots are nothing but basically are designed in front end to work with these models in backend. So you interact with them in the like a human. So you will provided with the specific uh, input uh, area where you ask like what you want, and then it will respond. Similarly, nowadays we also see this recording option, so where you can just provide as a voice note, it will automatically translate and give you the answer. So those things can be done at the chatbot level. Then the v- variational autoencoder. So what is it? So it's a neural network that comprises the data into the latent space and reconstruct it. So this is used, what we discussed is the diffusion model. So where it will just destroy everything and then recreate the things. So basically this architecture is used to develop the any application or software which is specifically generating the images. So it has three components: encoder, uh, latent space, and decoder. So this encoder will compresses into the input as a image into the lower dimension representation. This is basically these three things will involve in the diffusion, how this process of destroying and recreation will happen. So mathematically how it turns, we are not discussing, but yeah, how it works, its basic component is the thing is what we discussed in diffusion models. The key features. So what are the key features for this architecture? Is it's good for the image generation, uh, anomaly detection, and data compression. So these are the features or use cases where this is being used. One of the example, as I mentioned in the uh, OpenAI, come up with the Sora for the image generation. So it's a less sharp output than the gains or GNs, but more stable tuning, because GNs, as I was doing research, still there are some tools which are going to develop and in the research phase. So this next architecture which gains or it's generative adversarial network. So it's a framework where two neural networks compete each other. So how does this work is, there is a generator that creates the fact data, for example the images. Then it has the discriminator. So this try to distinguish the real versus the fact data. And third is it will try to improve iteratively. So with the huge number of data and what uh, out of two neural networks, one is generating and one is monitoring, and it will try to improve the neural network. So that's where this gains is used. And if we talk about the where it is used currently, so it's produces highly realistic images, or we can say video and audio. You might have seen the videos for the deep fakes. So that's where this architecture or this is used. Also for art generation, which is near to realistic, you can say. So this is possible using the GAN architecture. Comes to the application part. So application of generative AIs, there are different use cases and different application. We might have already seen many tools being developed by different organizations. So one of the application is the text, so chatbots. So this has become very popular when the ChatGPT was came into picture. OpenAI announced, and then it was boomed that every everyone is now asking the questions on the ChatGPT and getting the response. So that's where now models like ChatGPT or Gemini's, Microsoft also comes with such tools, and there are lots of other models also came doing just for the text processing. There is also image processing. So we also seen there are some arts or design or this feature already included in the ChatGPT. We seen that the Ghibli images were very famous. So underlying it will use the previously what we seen one of the technologies, and it is trying to generate the images. Also same with the uh, audio and music. So AI generated songs already you can see on the internet. There are many people also generate songs using the AI with other person's voices and different covers. So OpenAI's voice engine is one of the example. Then comes to the video. So as I mentioned, deep fakes and animated. One example is Sora by OpenAI. So that does the or generate the videos. And here across this application, there are the things which is let's say you are generating video, then you just provide the text, it will automatically generate the video. So in audio case, I think I'm not sure if we write something and generate the audio, but it will provide one audio as a input, and then uh, the different audio would be the output. So these are the some of the applications we already are uh, doing this, and we already knows that. It's just that we didn't know that what technology is behind that, or how does actually it happens or works. Then there are some limitations and challenges also when we talked about generative AI. Then one of the limitations we see is hallucination. So this already in our last video also, RAG, when we discussed, there was a limitation of hallucination. So here this is AI generate nothing but the AI generates some false information. So you ask something, and then with whatever the knowledge it has or data it has, it will try to answer, and there is no guarantee that always it will be the correct answer. If the data itself are wrong or processing in between wrong, then you will get the wrong output. The second point is the compute cost. So as we discussed, it required the huge number of data sets, and also it's required the more processing power. That's where the computing such algorithms or mathematical things would be costly, and the training required the massive resources. And the third challenge is over resilience. So risk of reduced human creativity, uh, critical thinking. Uh, yeah, as some of the tasks we can still say it is not up to the mark, like how the human thinks. But will people are working on it, and they're not sure one day, who knows, it will be uh, replaces the like human. It's just that currently difference is human have the emotion, machine doesn't. So that's the thing. But yeah, uh, this is the one of the challenge at the moment in generative AI.
So I have a question. So should there be limitation on what generative AI is allowed to create?
Hmm. Yeah, that's the good question. So basically, generative AI or whatever we have discussed, the models. So at the starting, they don't know anything. You trained with lot of examples and data, and uh, then it will generate the output. Now for each task you have different thing. For example, you are just creating for the translation purpose, then you feed it with the so many languages with the whole dictionaries and how the structures are performed. If you have enough data, then it will generate. Similarly with the images, it can do, but it cannot do all the task. So it is designed and trained. If the data is there and it is trained, then it will perform that task, but it cannot do everything.
So I have a question. So, do you think generative AI will replace creative professionals?
Hmm. Yeah, that's the good question. And if, as my understanding or experience, what I see working with generative AIs, so yeah, initially, whenever the new technology comes, this fear will come whether the professional would be replaced by the new technologies or not. Uh, Initially, it will take also some time to adapt the things and to generate the new jobs out of it. These technologies, so that's where completely I would not say that it will be replaced. uh, of course it's starting, yeah, you will see that most of the repetitive task we used to do or professions, for example, doing the notes or who is doing the scheduling the things, we have some professions and they were performing. But now with the generative AI and AI comes, those tasks are performed by AI and you don't require those professions or those persons in place. So, but with the AI now, the next jobs you see it as prompt engineers or how effectively this AI can be used and optimized way you will produce the output. Then such kind of new jobs would be created, but it will take time. So of course, new technology comes, so that fear will come, like whether this will erase some professions and some of the jobs. But I would say we have to still wait and watch how it goes. I believe it should generate new jobs and new opportunity, and that's how the technologies should grow. The thing is, it is not very new as we discussed in earlier also. It started 1950s back, but suddenly now the technology emerged and most of the things gradually was developed and now at this point it suddenly we see that it is replacing many things or doing automatic things very easily, and it came very fast, so that's why it's difficult also to just judge that it will uh, just erase the jobs or uh, replace the human. I will say still it will take time and we have to wait and watch.
Okay, so our session has finally come to an end. So thanks for staying with us through this exciting session. We hope you find it insightful and you are walking away with a clearer understanding of how this powerful technology is shaping the future. If you enjoyed the video and want to keep learning with us, don't forget to like, share, and subscribe to our channel for more such informative content. See you in the next video.